Hello, my name is Julie, and today I'm really excited to present this paper titled The Wide, the Deep, and the Maverick, Types of Players and Team-Based Online Games for CSCW 2021. There's a good amount of literature on teamwork, but most of these works are on traditional teams where collaboration happens in the pretext of established relationships. But with the aid of technology, there's been a new type of teamwork, and we call them transient teams. These are short-lived teams made mostly of strangers. Think about open source GitHub collaborations or Wikipedia editing collaborations, or the topic of our paper, multiplayer online games. And while traditional teams can benefit from the internal stability and familiarity with their long-term teammates, transient teams may have to rely on other things for communication and coordination, perhaps relying on norms or conventions. So compared to traditional teams, individuals in transient teams are possibly more influenced by their personal styles, preferences, and experiences. Motivated by that, in this paper, we want to focus on 4 research questions. The first one is, what types of players exist in League of Legends? The second research question is, do their play styles evolve over time? And then we're going to look at, is any type of play style more or less successful? And is any play style better at adaptation to changes in the game? So a quick little background on League of Legends. League of Legends is a multiplayer battle arena online game. A game of League of Legends is a match that's typically about half an hour. In this match, 2 teams of 5 players compete with each other, and they try to destroy the other team's home base first in order to win. Now, these teams are primarily made of strangers. League of Legends match teammates together, so none of these people knew each other beforehand. Due to the nature of how League of Legends is set up, there's a lot of choices that users can make prior to a match. We focus on 2 types of these choices. One is picking a champion. There's more than 100 champions in League of Legends, and each champion comes with their own unique skills and abilities. And after picking a champion, you pick a position in the game. And so, because there's so many choices involved in League of Legends, we can calculate how diverse or how conforming a player is based on their patterns or behaviors in choosing champions and positions. So diversity is calculated as how often a user plays the same champion versus how likely they are to diversify their experiences with different champions and positions. Conformity refers to how their combination of champions and positions conform to established norms in the game. So for League of Legends, there is a lot of established best practices on how to play the game. If we look empirically at how champions and positions are combined, we can infer whether a combination is atypical or typical. So based on these 2 dimensions of user behavior characterization, we hypothesize that there might be 4 types of players. The Mavericks are high in diversity and low in conformity. The Generalists are high in diversity and high in conformity. The Specialists are high in conformity and low in diversity. And the niche players are low in diversity and low in conformity. To approach this problem, we cluster users via tensor factorization. So we rounded up users with at least 100 matches during the time frame of our study, and we put the individual users on the first axis. The second axis are their 100 matches. We look at 10 consecutive matches at a time, and we slide the window so that we have 90 groups of matches. And then the final axis is the behavioral indices, which we calculate for every 10 matches per user. After building this tensor, we apply tensor factorization to obtain embeddings for each user. And then we apply k-means clustering to get clusters of users that are most similar in terms of their behavioral progression over time. So after running that algorithm, we ended up finding that 3 clusters is the most optimal number of clusters for this data set. And we plotted their diversity and conformity indices over the match indices to observe if we can see any patterns in their behavioral characterization. For that, we can answer the first question, which is what types of players exist? You will see that the blue line has high diversity and low conformity, which means that they're mavericks. The green line has low diversity but high conformity, which means that they're specialists. And the orange line, they're not the most diverse, nor are they the most conforming, but they're still relatively high in terms of both diversity and conformity, which means that they're generalists. With this figure, we can also answer our Q2, which is whether their playstyles evolve. Now we can see that over their course of 100 different matches, their diversity and conformity indices as a whole stays pretty stagnant, which means that they don't really evolve over time. Their diversity and conformity levels is sustained at the same level. To measure our Q3, which is whether a playstyle has a better performance, we calculate the win rate, the true skill, which is a Bayesian player skill rating system, and their KDA, which is an in-game measure that serves as a proxy for how good they are in the game. And we plot the KDE of all three measures for mavericks, generalists, and specialists. And we find that consistently across all three different types of measures, specialists outperform generalists, who in turn outperform mavericks. We also look at contribution to teams. How likely is having a generalist versus a maverick or versus a specialist will help with the team success rate. And I'll just go over this really quickly, but we found that the single best player to have on the team is a very skilled maverick, but otherwise the best member to have on the team is a skilled specialist. The worst member you can have on a team is a very bad maverick, but the next worst is a bad specialist. And finally, to answer question 4, we look at how users adapt to changes in the game. League of Legends releases patches about every 2 weeks, so the game is constantly being updated and things are always changing. Therefore, we can measure how well a user reacts to a patch. And there's 2 types of patches that we looked at. One is patches that buffs champions to make them stronger, and one is patches that nerfs champions and make them weaker. We found that there are no significant differences when we buff champions. If anything, the results are very mixed. But when the champions are nerfed, we found that mavericks and specialists are especially impacted in terms of their KDAs. But generalists remain at a very consistent level. So that would mean that generalists adapt better to patch changes. So in conclusion, in this research, we found that there are 3 types of players in League of Legends: generalists, specialists, and mavericks, and that we found that their playstyles are consistent over time. As for their performance, we found that specialists are better than generalists and are better than mavericks. But in teams, we found that mavericks are high risk, but also high reward. And finally, for adaptation, we found that mavericks and specialists are negatively impacted by adverse changes in the game, whereas generalists adapt relatively well. And there are a lot of implications of this research, for example, on game design, user-related research. We also offer an understanding of how online, ephemeral, and anonymous teams work and collaborate. The contents of our research can also improve team coordination, team communication, and how we can maximize the individual team player experience. And that is it for this presentation. Thank you so much for watching this video. I will see you at CSCW 2021.